Yeah, okay. So, meanwhile, we will start slowly. So, today's session is basically on week 7 content. So, what we are going to do is just revise the topics of week 7. And also, I just wanted to show you one thing that we have released a book for week 7, 8, 9. How many of you have gone through that book or just opened or just know
Yes,
about this book
Yes,
at
sir.
least?
yes, sir. Yes, sir.
Okay. Anyone who doesn't know anything about this, like how come, where come this textbook came? Hmm? Yeah. So those who are not,
Yeah, actually, I just came to know about this book.
yes, yes. So those who are not aware of this textbook, just go to this supplementary content.
Okay.
And in that there is a row books, there is a tab books. Just click on it. It will redirect you to some drive link, and in that there is calculus book, calculus.pdf. Okay,
Okay, fine. Thank you.
so you can get it from there, and in that we have week 7, 8, 9 completely covered in that book. So basically this book was prepared by few of our instructors. So precisely max 2 instructors, mathematics 2 instructors. So they prepared this textbook. Therefore, once you go through this, this will connect to our video lectures. So you might relate your video lectures with this particular book, because yeah, the authors of this book are our instructors only. Okay. Okay. Any pre questions before we start this lecture? I'm seeing all new set of people. Yeah, Bishwajit Roy, I know. Raghav. Okay. Shall we wait for a couple of minutes or shall we start?
So it start at 10:05.
10:05? Okay. Okay, fine. So yeah, as I requested you guys, just post it in your respective groups or to your friends, whoever taking this Max 1 course, that there is a session now happening, so that if they are free they will join, or else there is anyway, it is YouTube stream, so they can watch it there. Okay, we will start at 10:05, and before that, any comments on week 7 or any compliments on week 7? Anyone?
Sir, I have a question. Can I ask?
Yeah.
This is related to actually Max 2. Some of the topics initially these weeks that are being taught were on Max 2, right?
Correct.
So will this be again covered in Max 2, or
No,
syllabus has totally been changed?
no. That was
Yeah,
moved to Max 1.
that has been moved to Max 2.
Yeah.
Okay, okay, sir. Okay,
And
sir. Thank
Max
you, sir.
2 directly starts with linear algebra.
Okay. Understood.
Any more doubts? See, this is the chance you get to ask your questions, okay? Okay, let's leave mathematics. Any other doubts apart from mathematics?
Sir, what is the syllabus for quiz 2?
Quiz 2, it is till week 8.
Okay, sir.
Okay, week 5 to week 8. But we say week 1 to week 8 because to remove any
Okay, sir.
ambiguities. See, if it relates to week 3, you might come and ask like it's out of syllabus. So
Okay, sir.
that is why to remove all those things, we say week 1 to 8, but we more emphasize on week 5 to 8. Okay.
Sir,
Hmm?
sir, what's the relation between trigonometry and limits and continuity, sir?
Relation between?
Yes, sir. Because the week 7 is first, starts with trigonometry and
See, trigonometry, we dealt with only the simple functions like how is sine function look like, graph of sine function, what are the properties of sine function, cos
okay.
and tan. That's it. We never dealt with formulas of trigonometry like sine square plus cos square is equals to 1 or.
Sir, but there is a activity questions which has a in which we have to remember the formulas.
Is it? I
Yes,
don't
sir.
think so. We have given you hints, I guess. In hint, we might provided you whatever is required with respect to
No,
trigonometry.
there's no such kind of hints
What
in
is
that.
that activity question?
Sir, I think it is activity 2, sir, of week 7.
Okay. Okay, just give me 1 minute to open it. Okay, 7.2. 7.2 first question, is it? Is it the first question or fourth question?
Sir, the whole activity is
Okay.
based on trigonometric functions only, sir. We have to remember the formulas.
Oh. Oh, you mean formulas is like sine 180 plus theta, cos 180 plus theta, sine
Yes, sir.
180.
We have to match LHS and RHS like that.
Uh-huh. These things are discussed in the lecture also, right? Didn't we? Okay. Sure. We will discuss it today. If not, we will discuss it today. Okay. Okay.
Hello, sir. Good morning.
Yeah. Good morning.
So graded assignment 6, question number, I think last one, 12th question. There's one simple doubt, the given graph is a polynomial or not. I have chosen the given graph of polynomial, but at the end of the deadline, I think that the polynomial graphs are continuous and don't have breaks. So I just uncheck the option and I don't get the marks. So one basic question, sir. I know how graphs of polynomial goes, like how it is displayed. It is already mentioned in lecture and already been in revision. But in this graph, can we misinterpret like breaks because the lines are not in continuity?
Okay, which
If
question
you,
is that?
so last question, graded assignment 6, question number 12.
Question number 12.
Yes, sir. Last question. I marked as a polynomial, but at last moment I unchecked the option, which
The
is
given
mistake.
graph
Is
is
the graph of polynomial. Yeah, this option.
Is the graph is a polynomial?
Yes, you seem surprised, sir.
Even answer seems surprised, right?
Yeah. That's my point.
It's not a polynomial.
Yeah, how the answer is correct, sir.
It's not
The
correct,
graph
right?
is the log of the polynomial. Why
Yeah.
it is correct? My answer is also got incorrect.
The given graph is a graph of polynomial, sir. The option is correct. I was like, so how can it be polynomial? It is not continuous curve.
Given as correct, is it? I
Yeah.
the answers are only 3 options.
Yeah, sir. The accepted answer consists the given graph is a graph of polynomial. It's
No,
clearly
I am
stated.
not seeing that. Let me show you what answers I am seeing.
Okay. You can share, sir. Because if it is graph of polynomial, yeah, the last question.
So the accepted answers are the given function is not defined in the restricted domain. This. the range of the given function could be minus infinity to plus infinite?
No, sir. But in my portal, I can share screenshot or screen share whatever you want. Graded assignment 6. The correct accepted answers के अंदर 3 options हैं. And the second option goes like the given graph is a graph of a polynomial.
Okay, इसमें देखो, and which option is missing? Which option is replaced?
The second one, the range of the given function could be minus infinity to infinity.
This got replaced with the graph given.
The given graph is a graph of a polynomial.
This is
Sir, in
also-
my portal, this option is also missing.
Yeah.
This graph could be this graph of fx could be a graph of log 10 function.
This option is missing, is it?
No.
Yes.
Options are
Nee, in
different
the
for
correct answer.
options are different for everyone, but I want to know how the answer is showing the graph of given graph is a polynomial.
That is a mistake. That is a mistake. It is not a polynomial.
Okay. So
Okay,
it
we
is
will-
showing in graded assignment. That's why I raised the question.
Okay. I will.
Sir, I have a doubt in
so
question number
I have
11.
so same doubt I have also.
Hmm.
Sir, the Saad, what Saad has raised, I have the same doubt, sir.
Okay. We will.
Because
I-
this
last
graph
time-
cannot be a graph of polynomial.
Yeah, last time, in last moment, I have unchecked that one. And after that, that's why I got 0.67 marks on that.
Okay, we will. I will just look into this after the session.
Sir, graded assignment 5, question number 12.
This is graded assignment 5.
Sir, 11th
Yes,
question.
yes.
in the
Yes, sir,
graded
question.
assignment.
Okay, any questions in graded assignment 6 first? 11.
11th. Sir, first option is correct or not?
First option.
Not correct. You can make graph of
Plot the
polynomial.
graph, no? We have taught you how to plot the graphs, right?
But sir, when I plotted the graph, it is showing first option correct. Minus infinity to minus 2 and 4 to infinity is 1 to 1.
And that was also my confusion. But if you take both union, and then it would be not 1-to-1 function. It is 1-to-1 between minus infinity to minus 2 and 4 to infinity, but it is not in union.
Okay, what is the degree of the polynomial? 1, 2, 3, 4, 5, 6,
Minus
7,
x to power 10.
8, 9, 10, right? Degree
Yes,
of the
sir.
polynomial is 10, right?
Yes, sir.
It is an even degree polynomial. If it is an even degree polynomial, end behaviors will be either both the end behaviors will be on one side only. Either it will be the downside or the upside. Correct?
So downside, yes.
Yeah, either sides. But if you see the leading coefficient, it is negative, so it will be on the downsides. So whatever left of -2 and the right of 4, it will be on the downside. Just plot the graph, you will get it. So if both are on the downside, if you use horizontal line test, so one horizontal line will intersect at 2 different places, which fails the property of 1-to-1, and it will not be 1-to-1. I guess you are confusing with the plotting the graph of a polynomial.
Yeah, one general question.
Hmm.
So, how many number of graded assignments I have to clear to attend quiz 2?
Attend quiz 2. Quiz 2, you don't have anything, I guess. You are eligible to write quiz 2, or even though if you didn't write quiz 2, you can write end term.
Okay, fine.
Sir, I have one question.
Hmm.
I wrote my qualifier in March 13th and quiz 1 in June 5th. Will the best of 2 be
Best of
considered?
2 we consider, correct.
Okay, sir. Thank you, sir.
Now
Sir, graded assignment question number 12, sir. 5 में.
5, okay.
Yes, sir.
I'm just opening. 6 हो गया? 6. Any doubts in 6? If no, we will move to 5.
Question number 12. Sir, how B option is correct?
P of x and Q of x are even functions.
Sir,
Okay.
neither, sir. I have understand even, but neither.
You understood neither one, huh?
No, sir. I have understand Px and Qx are even functions.
Okay,
Yes.
okay. You didn't understand this. F
Yes,
of x
sir.
and g of x are neither even nor odd. See, even functions are symmetric at around y-axis.
Yes, sir.
Is f of x is symmetric around y-axis?
No, sir.
No, right? And odd functions are symmetric around origin.
Yes, sir.
Origin. If you see with respect to origin, is f of x is symmetric?
But sir, it will cut the x-axis at once. Then it will be odd function, maybe.
No, Yugandhar, you were there when Solve with TA session is going on around before the deadline.
Even I just
before the deadline, I explained this to Biswajit how to identify odd and even functions. If it is symmetrical to y, it would be even, and if it is symmetrical to origin, it would be odd.
It would be odd. Correct.
Okay, sir.
Or do one thing. Just invert your graph with respect to y-axis and again invert with x-axis. That is what symmetric around origin means. Okay. So what you have to do is you just invert this graph around y-axis. Then it will become like this. Correct? Like
yes, sir.
Now again invert this graph with respect to x-axis. Now it will go downwards like this.
Yes, sir.
And if you do like that, you should get the same graph. If you didn't get the same graph, after inverting along y-axis and x-axis, if you didn't get the same graph, it is not odd function. If you get the same graph, it is an odd function. Here you won't get the same graph.
Sir, can you again explain it?
Okay. So in order to check even functions, what you have to do is you have to invert your graph along y-axis. So if my graph is like this, now the given graph is like this, right? If
Yes,
you
sir.
invert along y-axis, how will you get? Something like this.
Yes, sir.
Correct. So if you invert along y-axis, if you get the same graph, see for example, this particular graph, if you invert along y-axis, you will get the same graph, this blue graph itself, right?
Yes, sir.
If you get like that, those are even functions. So symmetric, if it is symmetric means if you invert the graph, if you rotate the graph along y-axis 180 degrees, if you get the same graph, then those are symmetric along y-axis. So these type of functions are called even functions. Okay. For odd functions, you invert along y-axis and then you invert along x-axis. Now you should have to make a mirror image along x-axis. Now this will become like this. Something like this. You make this as inverted. Now this point will become this. With respect to x-axis, you should do. Now this green function is different from this red function. So therefore, this is not an odd function. What we know that odd function is x cube is an odd function, right? Now you can check it using the inverting along y-axis and x-axis. If you invert this green function, you will get like this. And after this graph, now this graph you need to invert along x-axis. So if you invert it, you will get this graph itself. So you take a mirror image along x-axis, then you take that mirrored graph mirror image along x-axis, y-axis and x-axis. So in order to check the odd functions. So if you get the same graph, that is an odd function. If you don't get the same graph, that is not an odd function. Okay.
Okay, sir.
Sir, one quick question, sir. Is there any difference between decreasing and is strictly decreasing?
Yeah.
What is that, sir? Is strictly decreasing and decreasing. I got one option wrong due to this. Because the graph seems decreasing, but I marked it is strictly decreasing and it was wrong.
So this is what you have to do. So after doing this, you need to get the same graphs in order to satisfy this criteria. Now, strictly decreasing and decreasing.
Yes, sir.
So strictly decreasing.
Is it
And-
is a steep turn or sharp drop?
Not sharp drop. It's actually like even the graph didn't drop also, it is considered as decreasing function. So decreasing condition is if x1 is greater than or equals to x2, f of
Yes, sir.
x1,
You have explained it earlier. I have also noted it.
strictly decreasing is the inequality sign goes off. So it should be like if x1 is greater than x2, then f of x1 is greater than f of x2. So the difference between these two is if you have any constant function, let's say f of x is equals to some 2. So how will be the graph of this function look like?
Straight line, sir.
Straight line, right?
Yeah.
Straight line.
2 at point
Something
2.
like this. Now you see this particular condition will be satisfied by this function.
Yes, sir.
Decreasing means inverse, right? If you pick any two x1 and x2, this is x1, this is x2. Your x1 is less than x2.
Okay, so it would be also equal, and hence you can say it is decreasing. Now I get it, sir. And when it is strictly decreasing, then it should not be mentioned equal in it.
No equality sign will be removed. It should be strictly decreasing, means it should always be decreasing, continuously decreasing. Okay,
that is some new thing, sir. Thank you.
Like
and
this.
Sir, yes, sir.
So this is a decreasing function. So this is a decreasing function, but it is not strictly decreasing function because at some point the graph is actually stabilized for few values.
Okay, so that's why it is. Yeah, I was referring to graded assignment 6 question number 4. It is a function log under its quadratic function, and I have plotted it after seeing the solution. I plotted into Desmos, see if I am wrong or correct. So it is saying between interval 2 to infinity, and it is seems decreasing, but for very little instance it is a straight line. That's why the option is my wrong is strictly decreasing.
Correct.
Thank you, sir, for this explanation. I'm noting it down.
Yeah. So this is the difference between strictly decreasing and decreasing. So actually these constant functions are
and the straight lines are also decreasing.
Both increasing and decreasing. Okay, this particular constant graph satisfy both the conditions. So it will be decreasing as well as it will be increasing. But these constant functions are neither decreasing, neither strictly decreasing nor strictly increasing. Okay. So that is the difference between decreasing and strictly decreasing. Okay, it's already 20 minutes. Let's come to week 7 now. Okay.
Yeah. One more question. Graded assignment 5, question number 6.
Graded assignment 5, question number 6. Which screen am I sharing?
PDF, sir.
PDF. Okay. John. Question number 5 is like f of x is equals to 1 minus x whole power half.
The question number 6. The inverse domain of inverse function of y.
So what should be the domain of inverse function?
All positive value, but it is showing all real numbers. I don't understand why the negative number is considering here.
Why only all positive numbers?
Because sir, y inverse is y minus 1 ka cube root.
Okay.
So if we put negative number in y, then it becomes negative under cube root. So that's why I am omitting negative numbers.
Cube root is negative friendly. Okay. Cube root accepts negative values inside. Only the square root doesn't accept.
Okay, sir. Okay.
Why we?
Sir, y cube.
Huh?
Why cube root accept negative number? Why
Why
it's
cube
not?
root accept negative numbers is because, see, product of three negative numbers can be negative.
Yes, sir.
Okay. But product of two negative numbers cannot be negative. So this is actually, if I am doing cube root, what I am actually computing is, I am actually computing the three equal numbers,
Yes,
which
sir.
when product gives me this inside number. That is what cube root is. So I am finding this particular. So x into x into x. If x into x into x is this number, this particular number, what is x gives me the cube root of this number, right? So what is cube
Yes, sir.
root of 27? So it's actually 27 is actually 3 times 3 times 3. So cube root of 27 is 3. Okay.
Okay.
So that is what it gives me. So what is cube root of minus 27? So minus 27 is actually product of minus 3 times minus 3 times
minus 3.
Minus 3.
Okay. So cube root of minus 27 is actually, I take minus 3 times, and if I product it, I will get minus 27. So cube root of minus 10 is minus 3.
Okay, sir.
Okay. But here square root minus 4, what is square root minus 4? So I have to find x such that when x is multiplied with the x, I should get minus 4. So for which value of x does it satisfy?
2i.
I chodo, I is undefined for us. Okay. So in real, so we cannot write x into x where x belongs to real numbers, right? So this product becomes minus 4. There is nothing like that we have. So that is why square roots doesn't allow negatives. So it's not doesn't allow if you know complex, and if we include complex also, it is also a defined number, complex number. But as in this course we are considering complex numbers as undefined, so that is why we say square root under negative values are not defined.
Okay, sir. Got.
Okay. Yeah. Similarly, you can have negative values under fifth root, seventh root, ninth root. Okay.
Odd number of roots.
Odd number root you can have, but even number root you cannot take negatives. Fourth root, sixth root, this doesn't allow again negative value.
Okay, sir. Thank you.
Okay.
Sir, I have doubt, sir. Of graded assignment 6, question number 12. I have given correct answer, sir, but it is giving 0 marks.
Correct. Okay, we will rectify that. Already someone pointed this out. Actually many pointed this out.
The single option is given 2 times.
Okay.
And the answer is in that option.
Yeah. We will either ignore that question or we will give it an add score.
Okay.
Okay. Okay. Let's keep week 5, week 6 slightly side, and let's come to week 7. So week 7 we actually start a new concept in mathematics, which is calculus part. Until now we have studied set theory. So we started from natural numbers, later we studied set theory, later we came to functions. We dealt with exponential functions, logarithmic functions, and in that functions we have studied few types of functions which are one-to-one functions, and later we studied inverse functions, composition of two functions. All we dealt with functions. Now we take a function and we actually study few properties of that function. So whether the functions are continuous, whether function is actually having a limit, or it is taking sharp turns, or it is having breaks in between. So we actually study about functions now, particular functions. So that is what we do in calculus. So how the graph is changing, how the function is behaving at one point. So these all things we study, because actually in real life you see every data is being nowadays plotted onto the graph, and each point denotes some particular data in real world. So you need to study at each data point. So you somehow wanted to study at each data point. So in order to study at each data point, you need to know each point of the function. So how each point of that particular function behaves. So if I have given you f of x is equals to so something like, if I have given you f of x is equals to x square only. So you need to know what exactly is happening with this function. So if I say this is the profit I earn daily, if I am running a store, so this is the profit I earn. So x represents the day, so first day, second day, so the day when it started, and x square is the profit it is giving me. So day by day my profit is growing higher, but I just wanted to make sure, I just wanted to look into the future whether I should continue with this set of products, or if I change my products, my profit will turn out to be something like x cube minus 3, something like this. So if I change my products and move, if I have to move to this, or I should keep continuing into this. So in order to understand these things, you need to know what all f of x is equals to x square, how this x square behaves and how this x cube minus 3 behaves, in order to judge your future. So in order to move for better strategies, you need to understand these graphs and everything you should know. Not only graphs, you need to know each and every point on that graph, and where the bends, curves, where the disconnection happens. So not everything in our real world will fit into this x square and x cube curves. It will be like uneven, something we can't even predict. Sometimes it rises, it lowers. So you need to know where it is bending, where it is taking sharp turn. In order to predict future, you need to study present data, past data and present data, to predict the future. That is what we do as a data scientist in any places. So in order to understand this, you should understand these things first. So these graphs first. So for that, calculus is very base step. If you didn't understand calculus, it will be much harder you to become a data scientist or a programmer. Okay. So until now, however you studied, this particular calculus part is, don't move ahead if you are unable to understand the things. So try hard, work hard to understand what actually happening in calculus. Okay, let us start now. So let us revise quickly what all things we have studied till now. So we know a relation is defined between two sets, A and B. So A cross relation is a subset of Cartesian product A cross B. So any relation is a subset of Cartesian product, and among those relations, we say one particular relation is a function if for every A, so for every element in A, there is an element in B, there is exactly one element in B that maps with this particular element A. So you see, that is how we define a function with respect to relation. So we say f is a function from A to B. So this is the denotion of a function. So where A is the domain, so this is the domain. B is the codomain. So we define functions from domain set to domain to codomain set, and where we actually map one element from A to exactly one element in B. So for every A belongs to A, there is exactly one B belongs to B, such that A comma B belongs to this function. So this f is nothing but the relation. So every function is a relation, but not every relation is a function. Okay. Now if A comma B belongs to this f, then we write f of A is equals to B. This is the denotion of a function values. So f of A means, so A is the input here and B is the output here. So we call B as the image of A under F. So these are mathematical terminologies. So this image is nothing but this. So B is called, the output is called the image of A under F. So this is the definition of a function in terms of relation. Okay. So yeah, so one example is this. So this is a machine. So what we do is we input plain cloth of a particular size and color, and the output will be of a t-shirt of a particular size and color. So what this clothing machine does is this actually stitches the t-shirts. So you just input the plain cloth with some particular size and color, it will give us the t-shirt of a particular size and color. So if you input one plain cloth, it will give me one output, one t-shirt. So if you input, it doesn't give me like if you input one plain cloth, it doesn't give me two different t-shirts. So one input, one output. This is how function behaves. Now, yeah, as we already talked about domain and codomain. So if this is a function a to b, where a is called the domain of f of the function f, and which is denoted by domain of f, and sometimes we simply denote it as dom of f. So these are called domain of f. So a is the domain of f, and b is called the codomain of f. And range, so or image also we call it as image. See, this is the technical term. A technical term we call, and even this is also a technical term, but we generally use range only. So the range of f is the actual outputs we get. So
Sir,
for every,
sorry to interrupt one thing. So
yeah,
image and pre-image, these are single element of range and domain, right? Not the whole range and domain, as you told in the revision class.
sorry, I didn't get it.
Image is the single element of range, right? Not the whole image is like if.
See, yeah, that is why we generally take this as range. Sometimes we simply call image of f. Okay. So if you see image of one element a in your set a, if you say like this, then it refers to one element. So if you are referring image of one element, then that is referring to one element only.
A single element. Okay.
Image of function, this is f. So I am referring to whole function here.
Okay.
Not one particular element.
Okay.
Okay. So here we see, if you see b is the image of a. So here a is one element, one particular element. So that is why we call b as the image of a. So here it refers to one element. But when I talk about image of f, the whole function, I am talking about the whole function here. So then it is like the whole output set. Okay. So that is why, in order, many people will confuse, we generally use range as the complete output, set of output values. We call it as range of the function. Okay.
Yes, sir.
So what this range is actually is, so what all the elements in A map to the elements in B. So we collect those output set, and that output set is nothing but the range of f. So you see, for every a belongs to this a, f of a. So we are collecting all f of a's for every a in a. And this particular range is always subset of our codomain. So range is always subset of codomain. Okay. Yeah. See, this note we already discussed. All functions are relations, but all relations are not functions. So there might be relations where one element in A maps to two elements in B. So those are our relations. Yeah, there is an example also. So you see here is a relation from one set to other set B. So one set is 1, 2, 3 and other set is AB. So this is the relation 1 comma A. 1 is mapped to A, 2 is mapped to B, 3 is mapped to A, 1 is mapped to B. So now if I show it like this. So 1 is mapped to A, 2 is mapped to B, 3 is mapped to A, and 1 is mapped to B. So now you can see one input, we are getting two different outputs. So for one is actually mapping to A as well as B. So this violates one input, one output property of the function. So this particular relation is not, this is not a function. So yeah, so these are some relations which are not functions, but every function is a relation. And yeah, so with respect to codomain range, if there is a function f from R to R, so this particular thing denotes that this is one set of real numbers, which is the domain, and this particular set R is the codomain. And here domain and codomain are the same set of real numbers. So such that I have defined a function as f of x is equals to x square. Now given that both domain and codomain of f are R, but if we see the range of f, so the range of f is actually the set of all outputs.
All positive, yes, sir.
Yeah, if we draw the graph also you can get. So the range is actually all positive reals, including 0. So it is from 0 to infinity. So where the range is actually the subset of this codomain. So this is not a surjective function. So if you remember surjective 1-to-1, so this particular function is not a surjective function. So in your surjectivity, your range should be equal to the codomain. Okay. So yeah, let's move ahead. Yeah, let's come to this types of functions. So we actually started right from the week 2, we actually started studying about linear functions, which are also called as straight line. Right? So this will be of the form f of x is equals to ax plus b, where a comma b belongs to real numbers and a not equals to 0. Why this a not equal to 0?
Sir, then it will be a constant function if x equal to 0. Constant.
Constant function are not linear functions, is it?
Yes, sir. Yes, sir. That's why it will a does not equal to 0.
Sir, it will not be a constant function, it will be a constant value, no?
Similar, right? If it is constant value also, the graph will be like a constant.
Sir, when you say function, you mean you have something changing, right?
Functions have some variability, right?
Yes, sir.
Functions have some
variability. We have to put some value and we can get some value.
So f of x is equals to b is not a function, is it?
Exactly. No, sir.
This is not a function.
This is not a function. Yeah.
How many of you agree with him?
No, sir, this is a function. But this is a constant function. Means
it's
a
constant. This is a constant function.
Whatever value we put for x, it will give a straight line.
It will give me the same value b.
Yeah, same
for
value
every
b.
input we get one particular output only. We are getting one particular output only.
Right.
This is a function.
But where we will put the value of x?
Where will be?
Where
No
we
need to
will
put.
put
No
the
need to
value
put.
of
It's
x.
independent of x. That's it. So you see, there is a water can vending machine, water bottle vending machine. Okay. So it doesn't know how much money it should take. If you input 1 rupee coin also, it will give you one water bottle. If you input 2 rupee coin also, it will give you one water can out, one water bottle outside. If you input 10 rupee coin also, it will give me the one water bottle as an output. So how that function works, how that machine works. So whatever the money you input, you will get only one water bottle outside. So don't you call this as a machine?
Yes, sir. That is a function.
This is a machine. This particular thing is a machine, right? So
Yeah.
whatever you input, you will get one water bottle as an output. So that is how this particular constant function also behaves. F of x is equals to b, or f of x is equals to 2. Just now we have seen f of x is equals to 2. So how the graph will be? It will be like a straight line. So whatever the value of x is, you will get the output as 2. But you are getting only one output, right? If you use vertical line test, this passes. This particular line passes the vertical line test. So it will cut only at one point. This is not one-to-one function. That's it. This is a function. Okay. So if a becomes 0, what happens is your slope will become 0. Okay.
It becomes constant function.
It becomes a constant function, and your linear function will convert to an horizontal line. Okay. But we are not nothing to study with horizontal lines. So there is nothing to study with horizontal line. So every linear function has some slope, where a is the slope here. So that is why we take slope as not equal to 0. So these are some linear functions, and the graphs of linear functions may look like this or this. These are straight lines which have some angle with respect to x-axis. Okay. Later week 2, then we studied in week 3, we studied quadratic functions which have the form f of x is equals to ax square plus bx plus c. Here also we have this condition like a should not be equal to 0.
Sir, if a is 0, then it will become a linear function.
Linear function. It will go into the category of linear function. So here also a not equal to 0 for in order to be a quadratic function. So this particular quadratic functions, if you want to draw the graph, this will
Parabolic graph.
Parabola upward or downward. Okay. So depending upon the value of a. So here also depending upon the value of a, the straight line will be either negative slope or the positive slope. So if a is positive, you will get the positive slope, which lines are like this. Lines will be like this. So acute, it will make an acute angle. If a is negative, then these lines will, the graph of that linear functions will be like this. Obtuse angle. It makes an obtuse. Here also, if a is greater than 0, you will get an upward parabola. If a is less than 0, you will get a downward parabola. So something like
Sir,
this.
Sir, in linear function, you had mentioned like if a equal to 0, it will be a straight line, sir. So it will be like many to one function, sir. So whatever input we get,
yeah, many to one. It's not one to one. That's it.
Okay,
not one to one is nothing but many to.
Okay, sir. Thank you.
See, here we are observing the leading coefficients only. So in order to draw the graph, we are only observing the sign of the leading coefficients. Even the same follows with polynomial functions also. In week 4, we studied about polynomial functions, and polynomial functions will be of the form f of x is equal to something like some coefficient an times x to the power n plus an minus 1 times x to the power n minus 1 plus and so on a1x plus a0, where only condition is an not equal to 0. If an becomes 0, that polynomial will not be of degree n anymore. It will convert to the degree n minus 1. So that is why we say an not equals to 0, and all other ai's will belong to real numbers. So these all can be 0 or non-zero or negative or whatever it is. But the only restriction is an not equals to 0 in order to say that this polynomial is a degree of n. So it should actually contain x power n term. So
yes,
in order
sir.
to contain that, this particular coefficient should not be 0. So here also the same thing. Depending upon the leading coefficient sign, our graph will vary. Okay.
Yes, sir.
So the graphs of some well-known polynomials will be if x cube, it will be like this. If it is x power 4, it will be somewhat like this or inverted, depending upon the sign of leading coefficient.
Yes, sir.
Okay. So yeah, these are some polynomial functions. Later we studied in week 5 exponential functions. So this is very different from what all other things are. So exponential functions will have form f of x is equal to a to the power x, where a belongs to real and a not equals to 1. So if a is equals to 1, again it becomes a constant function and a greater than 0. So why a greater than 0? We have studied this in week 5 itself. So in order to exclude the complexities, complex numbers, so we take a greater than 0 and a not equals to 1. Okay, and the domain of this exponential function is, anyone?
Real.
Set
All
of
real.
reals, right? So forget. सब
No
भूल
sir,
गए
no
क्या?
sir.
No,
No
no,
sir,
no,
no.
sir.
No,
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 nothing
right?
No,
forget.
sir.
Okay. Okay. Domain is real. Okay, now tell me what is the range then?
0 to infinity.
0 to infinity.
0 to infinity, closed
All
or
positive
open?
values.
Sir, open.
Interval.
Open.
Yeah, open interval.
Right. So exponential functions have graph like this. So depending upon the value of a here also, either it will be like this. If a is greater than 1, this is how the graph will be. If a is greater than 1, and if a is less than 1, and if a is in between 0 to 1, the graph will be like this, 0 to 1. So these
Decreasing.
all things we studied. And exponential function, inverse of exponential function is nothing but the logarithmic function, which will be of the form f of x is equals to log x to the base a. So here
Sir,
also the same thing. Yeah.
sir, a is less than 1. Is it strictly decreasing or
It will
only
be strictly
decreasing?
decreasing. It will be strictly decreasing. This is not a straight line actually. If you zoom it a little, it will actually decrease at every point.
Yes, sir.
Okay. So it might look in
Thank you, sir.
Desmos, it might look as a straight line because we are looking at the scale of 1. Our Desmos graphs are scale at 1. So you might look it like a straight
Sir,
line, but it's not a straight line.
here in logarithmic function, it has written like the domain is the set of all positive real numbers. So real numbers means like it could be negative, no?
Positive, that is why we mentioned positive, right? Set of all positive real numbers.
Okay.
So what are positive real numbers?
0 to infinity.
0 to infinity. Yeah. So 0 to infinity, we don't get negative values, right?
Right.
So
then the domain and range would be same, no?
Domain and range of which function?
Like for logarithmic, because range is also. Oh no.
Range
No.
you will get whole R. See, that is why don't confuse about range and domain of logarithmic functions. If you know the domain and range of exponential function, it is sufficient.
Okay.
This is actually the inverse function of exponential function. So the domain of this exponential function will be the range of this logarithmic function, and range of this exponential function will be the domain of this logarithmic function. Okay. Yeah. So range of this f, this g maybe, is nothing but set of reals, and domain of this particular g is 0 to infinity. So logarithmic functions of this part. Now the new things we study in this week 7 is trigonometric functions, and very important function which is floor function, greatest integer function. Okay. So let us study one by one. So trigonometric functions, we actually study only these three: Sine X, Cos X, and Tan X. Okay, let me take one new page. Okay, let us see floor function first, and we will go to floor and ceiling first, and we will go to trigonometric functions later. So this floor function is actually floor. Where will the floor be in our room? In our normal house में where will be the floor कहाँ पे होता है?
Below or foot?
सबसे नीचे सर.
Towards the bottom.
नीचे होता है. So it will be downward, downside. So the same, that is why we use floor here. what floor does is actually, this is a function defined from set of reals to set of reals, where f of x is denoted like this. F of x will be equals to, this is the denotation of a floor function. So what it actually gives me as output is, whatever the x you input, it will give me output as the greatest integer value less than or equal to x. So if I input 1.2, so f of 1.2 will be floor 1.2. What I have, this output is actually the greatest integer which is less than 1.2, which is the greatest integer which is less than 1.2. So what are the integers? Okay, what are the integers which are less than 1.2?
0, 1.
1, 0, minus
2, 0,
1,
minus, pura minus
3, and so on. So among this, which is the greatest one?
1.
Plus 1.
1. Correct. So this will give me an output as 1. So similarly, if I input 0.2, so what is the greatest integer that is less than or equals to 0.2?
0.
So what it actually takes is, it takes the below integer. So whatever the output, so now what is the greatest integer less than or equals to 1?
1.
1. So the same integer. So if my input is an integer, it will give me the same output, same value as output. Except integer inputs, if I input any real number, it will take the below integer, below. So floor means below. So 7.5. What is the floor of 7.5?
7.
7. You take the below integer. You remove this and you take this integer. Whatever the decimal after point is there, you just ignore it. 7 will be the output. Whatever it is, 1927.7354, something like this. Floor of this will be 1927. So you should take the below integer. So that will be the greatest integer less than or equal to x. So this is what floor means. Now ceiling is just opposite of it. Okay. So ceiling कहाँ पे होता है हमारे घर में? It will be above, right? Now the same thing happens here also. This is the denotation of ceiling. So ऊपर में we will give this closing, and for floor we will give closing in the downside. So what this gives me is smallest integer value greater than or equal to x. So the same 1.2 I wanted to take. So the ceiling of 1.2 is, what is the smallest integer that is greater than or equals to 1.2? So what all the integers are greater than 1.2?
2, 3,
2, 3, 4, 5,
2 to
6,
infinity.
2 to infinite. Which one is the smallest among these 2 to infinite things?
2.
So therefore the ceiling of 1.2 will be 2. So like this 0.2 ka ceiling?
1.
So 3 ka ceiling? So what
3.
is the ceiling? 3 only. So the same thing goes here. If your input is an integer, it will give me the same integer as an output.
Sir, what did you do for ceiling function of 1.2?
See, we just took the above integer. ऊपर वाला integer लेना है. So for ceiling, you should take the above one. For floor, you should take the below one. So floor and ceiling actually gives you the understanding of these functions. So floor कभी भी घर पे नीचे होता है. So you should take the below one. So 1.2 का below integer is 1. Just below integer is 1. Similarly for ceiling, what you have to take is the just above integer. Just above integer. So for 1.2, the just above integer will be 2. So that is how the ceiling and floor functions look like. And this is one example you see. Consider a floor function in the domain -1 to 2. So if you consider floor function in this domain, in this particular domain, how it will be? So if your h is in between -1 to 0, so whatever the value I take minus, so now tell me minus 0.5. So So what is the floor of minus 0.5?
-1.
-1.
Yeah, you should take
Minus.
the below integer. So minus 0.5 से नीचे जो भी integer है उससे greatest लेना. So -1 will be the just below integer of minus 0.5. So the floor of minus 0.5 will be
0. Sorry, -0.5.
sorry, ceiling of minus.
हाँ 0 होगा.
Yeah.
Ceiling 0.
0. So don't confuse. Ceiling means you should just take the above integer. Floor means you should just take the below integer. So
Sir, could you please explain the graph that you have drawn above, like how to obtain that graph?
Which graph?
If you just scroll up a little.
I didn't draw any graph, right? No, it not came yet. You are in the future, I guess.
No, sir, I mean to say the graph that you've drawn that's parabolic, that intersecting. The last one.
This one?
Yes, sir.
Exponential guy.
He was talking about the above one. You're right, sir.
Yes, sir.
This exponential one.
Yes, sir.
What do you want to know?
Sir, I didn't understand as to how this graph is behaving.
See, it's just the exponential function graph. Nothing new. If a is greater than 1, it will be like this. It will grow like this. If a is in between 0 to 1, it will decrease like this. It will decrease. Na? If a is 0 to 1, the value of a is in between 0 1. So if I take power which are in between 0 to 1, it will actually decrease, keep on decreasing.
Okay, sir.
See, if you wanted to know in detail, week 5 lecture, this is pretty easy to understand. If depending upon the value of a, the graph of exponential value changes. Exponential graph changes.
Sir, just now you have said like for -0.5, see, this is for floor function, na? So it would be the smallest one or lesser than -0.5.
Lesser than 0.5, minus 0.5. See, floor means lesser than minus 0.5. Just less than floor, you should take the below integer, just below integer.
Okay.
For ceiling, you just have to take the above integer. Okay. So I will also tell you why these are called as step functions. See, these are called as step functions because the graph of these functions will be like steps. Okay. So,
sir, in example 1.2.4, domain is -1, 2, but the function is not defined at 2.
Okay. Okay, it is not defined at 2, or else you just open this bracket. Okay, it was a mistake.
Okay,
you
sir.
should also add that. Okay, so let's plot this step functions.
I think it's like just like the graded assignment question.
Yeah,
Question.
correct.
Logarithm.
So for 0 to 1, so whatever the values are in between 0 to 1, 0 including and 1 excluding. So whatever the value I take, 0.5 or 0.5, 0.6, 0.7, 0.73, 0.992, whatever I take, if I consider the floor of it, floor of these numbers, so I will get 0, right? So whatever input I give, if my input is in between 0 to 1, my output is 0. So we are drawing the graph for floor. So that means from 0 to 1, my graph will be on x-axis. 1 excluded. So excluding, we denote it as open circle. Including, we denote it as an closed circle. Okay. So 0 is included here. And similarly, from 1 to 2, if any value I take between 1 to 2, 1.1 or 1.2 or 1.35 or 1.72. So whatever real number I take in between 1 to 2, floor of those numbers will be 1. So the greatest integer which is less than these real numbers is 1. So the graph will be like this. And at 2 it will be open. This will continue. So this is 1, this is 2, this is 3, this is 4. And on the left side, so whatever the values are in between -1 to 0, -1 closed. So -1, -0.99, -0.98, -0.987423, like this. If I consider the floor function of this, floor of these values, my output will be
-1.
-1.
-1. So the below integer I should take. So for all these numbers, the below integer is -1. So this is -1, -2, -3. So if you see the graph here, it is like a steps. 1, second step, third step, 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 step. So that is why this function is called step function. This function is also called as a step function. And if I draw the graph of ceiling function here itself, you can see the difference. So ceiling, I will draw it with black. So we are drawing ceiling function. Ceiling function means whatever the real number I have given you, I should take the above integer, just above integer. Now in between 0 to 1, 0 to 1 closed, 1 closed, 0 open now. So 0.1, 0.2, 0.325, 0.75, 0.992. So the ceiling functions of these particular real numbers will all be equal to 1. So ceiling function is just take the above integer, just above integer of these values. So above integer of 0.1 is 1, 0.2 is also 1, 0.325 is also 1, 0.75 is also 1. So whatever the integer, whatever the real number I take in between 0 to 1 closed, I will get output as 1. So 0 open, 1 closed. So similarly in between 1 to 2 I will get 2. So here it is open. Similarly here.
Hello, sir.
Huh?
Can you please explain this step function again? Actually, I lost my connectivity. That's why.
See, the step function is actually we are drawing the graph of this floor and ceiling. Okay.
Yes.
It's nothing new. So you know the function now.
Yes, yes.
Right. Taking that function, you try to draw the graph. We are trying to draw the graph. That's it. So that particular graph turns out to be like steps. So for floor, it is like this. Even for ceiling also, it is like that. Steps. We know steps, right?
Yes.
So it will look like steps. Our graph looks like steps. So that is why these functions are also called as step functions. Okay. So you just draw the graph. That's it. So f of x is ceiling x. This is the ceiling function. And our floor function is denoted like this. Floor of x. Okay. Okay, let's go deal with trigonometric functions.
Sir, may I know its application, step function?
Application.
Like in mathematics, I haven't studied calculus, so I don't know what are its applications. Just asking. Like we have seen all the quadratic, polynomial, everything. We have seen some application based questions. But what are the applications of these step functions, I wonder?
Okay. Suddenly, I cannot recollect. But meanwhile,
no issue, sir.
As
No
the
issue.
end of the course, as the end of this session, I will try to recollect.
No issue, sir. It was just sake of
Okay,
curiosity.
yeah, sure. Anyone having any applications?
Yes, sir, it is important in machine learning, I think. Machine learning.
In machine learning, is it? What application?
We study calculus there.
We study calculus there. He's asking application for this floor function and ceiling function. Any application, real life application where we actually use floor functions. See, rounding offs, we use this floor and ceiling.
The rounding of cost in shops, like if it is 0.5 paise, it is rounded off to
round off. Yeah, correct. See, bills, we calculate bills, right?
Yes, sir. Yes, sir. Rounding off.
Yeah, for bills, actually in restaurants, it will round off to the greatest integer, which is less than that. It will not go above. So if your restaurant bill is when you went to restaurant, you see if your bill is like 99.67, he will not make it as 100 if he is billing the thing. Okay, if you went to some normal restaurant, he will say 100. But if you're billing, then 99.67 will round off to 99. And even in shopping malls also, it will round off to greatest integer, which is less than the actual bill happened.
Got it, sir.
Yeah.
Sir, can the ceiling or floor function invertible if we restrict some codomain? Can we make invertible?
How? No, this floor and ceiling are not invertible because you see, you don't find any interval in which this function is 1 to 1.
Okay, sir.
No smaller interval also. Okay. So even if you consider some smaller interval around 0, also there are few points, there are infinite points which takes the same output.
So can we make it onto?
You can make onto by making your codomain as set of integers. Here itself, if I instead of this r, if I make this codomain as integers, set of integers, then this particular floor and ceiling function becomes onto.
Okay, sir. Okay.
So codomain, you should restrict your codomain. So you know that your output is in integers, then obviously your codomain will be like, we expect our output should be in the set of integers. Therefore, the codomain will become set of integers and your output also becomes set of integers. Therefore, it will become an onto.
Sir, the other tool that it becomes 1 to 1.
Sorry, your voice got break.
That it becomes 1 to 1.
Sorry. Still your voice is breaking.
From integer to domain of an integer and codomain take as an integer, it becomes 1 to 1 to.
Can you just post it in the chat?
Okay.
Okay. Okay. Domain also you are making integers, is it?
Yes, sir.
Then what's the point in talking about ceiling or floor function? So if your domain is a set of integers, then whatever integer you input, the same integer you will get as an output.
Yes, sir. It becomes x equal to x.
It becomes normal f of x is equals to x kind of graph.
Yes, sir.
Where you restricted your domain to be set of integers. So you will get these points. Only these points. Okay.
It becomes like a straight line.
Huh?
When we turn the points, it becomes straight line, passing through origin.
Still I can't hear you, or am I the only one, or?
No, sir, we can't hear.
Yes, sir. We are also getting the cracked voice.
Okay, so this is not an important thing to be discussing. So let's move and discuss these functions here. So f of x is equals to sine x is a function defined from set of reals to actually set of reals as the codomain. But if we try to draw the graph of this sine x, so now to draw the graph of sine x, we need to know at least few values. So the graph of sine x is actually called as periodic graphs. So I will tell you why it is called periodic and what periodic is actually mean. So sine x, actually sine 0 is 0. So the function, the graph actually intersects origin or passes through origin. And the maximum value of sine x is 1 and the minimum value of sine x is minus 1.
Minus 1.
So in between minus 1 and plus 1, it will oscillate. Okay, so this is 0 and it takes value 1, maximum value 1 at pi by 2, and again 0 at pi.
3 pi by 2.
Yeah, 3 pi by 2, it takes the minimum value.
2 pi.
And at 2 pi, it again takes value 0. So this pi 2 pi comes from here. So consider 360 degrees. So this is pi by 2, which is 90 degrees. Actually, pi by 2 is 90 degrees.
Pi.
Pi.
3 pi by 2.
This is 3 pi by 2.
2 pi.
And 0, actually we reach 0 or 2 pi, both are same. So again we reach to this line. So we start from here, we rotate 90 degrees, we rotate 180 degrees, we rotate 270 degrees, and if you rotate 360 degrees, we are at the starting point. Okay, it actually starts again from the starting. So even if you see the graph also, so the graph starts from here, the values takes like this. At pi by 2, it takes the maximum value, and at pi it will come again to 0, and at 3 pi by 2 it takes the minus 1 value, which is the least value the sine takes, and at 2 pi it again reaches to 0.
And 5 pi by 2 it again 1.
Yeah, it again goes to 1.
Sir,
so now,
can you please elaborate a little bit of phase, how it is work in this sine function and cos function?
How is?
Phase.
What is phase?
Pi by 2 phase between sine x and cos x. Cos 0 is 1. Therefore, the graph of cos started from the 1 at 0.
Okay, I didn't get what is phase. Phase means 0 to pi by 2, pi by 2 to pi. Is that what you meant?
Actually, Actually, I also am not clear about, but in my 11-12 knowledge, what like it is also not very clear to me actually. But I have heard about this term phase, but this is not clear to me.
Yes, sir. There is phase difference in physics.
Yes, yes, a phase difference, and is it
Phase
relevant
difference
here
is
also?
denoted by phi.
Phase difference in between the equation of waves, like y equal to a sin omega t plus phi.
Okay.
So is it relevant here also, or it is
No,
something else?
No. One thing, I am very poor in physics. Second thing, whatever this phase terminology, that is
that equation is oscillating waves in SHM or wave motion.
Okay.
I don't know.
Okay.
So you should ask someone who knows physics well and so.
Okay.
Okay. We don't have phase in our mathematics. We do have periodic in our mathematics.
Okay.
That phase part in physics only, like in AC currents and.
Yeah, maybe that is the thing you are talking about, I guess.
Yes, sir.
So see how this this graph is actually, so this angles is actually, whatever the angles we see, if you start from 0, you will be on the positive x-axis. So consider this as an x-axis. So if you rotate 90 degrees, you will reach to the positive y-axis. If you rotate 180 degrees, you will reach the negative x-axis. And from there, if you rotate one more 90, you will reach the negative y-axis. And if you rotate one more 90 degrees, you will reach the positive x-axis again. Now we have rotated 360 degrees. So for every 360 degrees, you will actually reach the starting point. Okay. Our starting point is positive. Consider it as x-axis, positive x-axis. So for every 360 degree, for every 2 pi. So again, you can start from here. From 2 pi, you rotate again 90 degrees. 2 pi plus pi by 2, which is 5 pi by 2. It will be positive y. Again, you rotate pi by 2. It will be 3 pi. Again, you rotate pi by 2. It will be 7 pi by 2. You rotate again pi by 2, you will reach 4 pi. So you see here 0, 2 pi, 4 pi, 6 pi, 8 pi. So for every 2 pi rotation, you are actually coming back to your starting point.
Yes, sir.
So even if you see the graph of this, so till 2 pi, the graph will be like this. And after 2 pi, it's actually the same thing. Same thing we are doing.
Basically, the period of sin x is 2 pi.
2 pi, yeah. So that is why the period of sin x is called 2 pi. Period means
repetition.
Repetition, yeah, correct. So how long it will take for me for repetition of my graph? So it will actually take 2 pi for me to get my graph repeated. So in order to get my sine graph repeated, so this particular shape will be repeated again and again. So the same graph will be repeated for every 2 pi, like this. Even the left side also, it will be
similar
for every 2 pi. So this left side means you are actually going backwards. So you start
negative,
from 0,
like minus pi by 2 and minus
yeah.
pi.
Now it will be like clockwise. So you go clockwise, minus pi by 2. This will be minus pi by 2. This will be minus pi, and again this will be minus 3 pi by 2, and again minus 2 pi. So here also you see minus 2 pi. Again you reach to the starting point, minus 4 pi, minus 6 pi. So the difference between these two, every two consecutive things are 2 pi. So that tells us that for every 2 pi rotation, we actually get the same graph. So this particular shape is being repeated for every 2 pi distance. So that is why we call the period of
sin x is 2 pi.
Sin x is 2 pi. Okay. If you know how to draw the graph of, at least if you know how to draw the graph of minus pi to pi, this particular minus pi to pi, then you know the graph of sin x on complete R. You can actually draw, you can actually repeat it again and again. So that particular shape you can actually repeat it. So this shape, minus
So,
pi to pi shape is this.
So for like all the positive values, we need to go for anti-clockwise.
Yeah. Correct. So angles will be computed anti-clockwise. Positive angles will be computed. See, this we studied in slope while calculating slope of a straight line only. So tan theta is the slope, right? And theta is the inclination with respect to positive x-axis, if you remember, in week 2.
Yes, sir.
So if this is a straight line, this particular thing is theta. So this is the denotation of theta. This is the angle made by the straight line with respect to this positive x-axis. This is the theta, and tan theta will be the slope of this line. So this is how we measure angles with respect to positive x-axis anti-clockwise. So for positive angles we measure anti-clockwise, for negative angles we measure clockwise. So this is the graph of sin x, and period of sin x is 2 pi. So this particular 2 pi you can consider from minus pi to pi also, or you just consider from 0 to 2 pi. So whichever. Okay. So what else? So this is the graph of sin x, and you see this particular graph is in between -1 and -1. Okay. So this particular, so we can confirm that sin x doesn't take output values more than 1 and less than -1. So it will always give me values in between -1 and -1 to 1.
Sir, why if your codomain is real numbers?
See, this
It's
is just we took codomain as real. You can take from 0 -1 to close.
Okay, sir.
Okay. Yeah. So yeah, and cos x will be like this.
-1 to 1 also comes under real number, right?
Yeah, yeah. So f of x is equals to cos x so cos 0 will be 1. So it will start from here. Pi by 2 it will take 0. Pi it will take the least value. 3 pi by 2 it will take 0. And again 2 pi it will take. So this is 0. This is pi by 2. This is 3 pi by 2. Sorry. This is pi. This is 3 pi by 2. And this will be 2 pi. So this is how the graph of cos x in between 0 to 2 pi. And also the same thing happens here also. So pi by 2, pi, 3 pi by 2, 2 pi. After rotating 2 pi degrees, we actually reach to the starting point only. So 0, 2 pi, 4 pi, and again 6 pi, everything reaches to starting point. So the same graph will be repeated again and again. So if you repeat it, it will be like this.
Sir, I have one question here. Cos of minus x is equal to cos x. How does it reflect in this graph? Like sine of minus x is equal to minus sine x, but cos of minus x is equal to cos x. So how these two difference reflect in the graph of sine x and cos x?
Reflect in the graph of, because see, you see, what is cos x? Why is cos minus x is cos x? See, this is nothing but this is f of minus x. Cos minus x is f of minus x, right? If
Yes.
f of x is cos x, cos minus x is f of minus x.
Yeah.
And this
Even
is
function.
equal to
This
f
is
of x.
even function.
This is an even function, right? This is becoming an even function.
Yes.
If you see the graph, if you see y-axis here, just now in the starting of the lecture we just discussed, even functions are symmetric around y-axis. Okay.
Yes.
So you see, if you rotate this graph 180 degrees along y-axis, you will get the same graph. Cos X graph will be same.
Okay.
Okay. So this tells me that cos X is actually an even function. From the graph, you will get it is an even function. And also from the function definition, even function definition, this will get satisfied. Cos minus X will be cos X.
Okay.
Because this is an even function. Cos X is an even function.
Okay. Yes.
From
Yes,
the
sir.
graph also you can see, if you know how to plot the graph. Just now we plot the graph, right? If you know cos 0, cos pi by 2, cos pi, cos 3 pi by 2, cos 2 pi, and the values in between those two. So this is how the graph will be. And if you complete this graph using this periodic property, this is how the graph will be. And this particular graph is symmetric around y-axis.
Yes, sir.
Okay. So this satisfies the property of even function.
Yes, sir.
Okay.
Yes.
And Sine X is, tell me by looking at the graph, Sine X will be?
This is non-symmetric.
This is not symmetric, but this is symmetric along origin.
Yes, yes. This is symmetric along origin.
So this is an odd function.
Yes.
So for odd function, what is the condition? F of X will be equal to minus F of minus X.
Yes, sir.
Yes, sir. So the same thing, if you consider F of minus X, it will be sine of minus X. It will be minus sine X. This will be minus F of X. So F of X will be equals to minus of F of minus X.
Yes, sir.
So sine X is an...
one question. Actually, I joined little late, 10-15 minutes late. That's right. Are all odd function symmetric along the origin, or is it only for this sine function?
No. It will be odd functions are actually symmetric along origin.
Okay, like all odd functions.
All odd, yeah, all odd functions.
Okay, thank you.
Okay, yeah, this is cos function. Even the same thing, period is 2 pi. So if I plot the sine function here, it will be like this.
Yeah. Okay.
Yeah,
fine, sir.
Okay, it will be like this. Somewhat like this. It will be pi by 2 shifted towards right side.
Yes.
Okay. You just shift the cos function pi by 2 the right side.
Yes.
You will get the sine graph.
And I think, sir, this is the phase difference between sine and cos.
Yeah, this will be the difference, and that is why sine x minus pi by 2 or sine pi by 2 minus x will be equal to cos x.
Right.
So if you shift pi by 2 degrees to the right or left, that particular function graph will convert into cos. So if you shift sine pi by 2 to the right side, that particular sine graph will convert into cos.
Yes, sir.
Okay. Yeah. And if you shift pi to the right or left,
sine will become minus sine x.
So you see this particular thing, if I shift to pi units right side, this will convert like this. Opposite of it.
Yeah.
If the value is positive, I will get negative value. If the value is negative, I will get the positive value.
Yes.
So that is why sine pi minus x. So I am actually doing 180 degrees shifting towards right side. So this will be minus sine x. So this is how you can remember this small formulas, like how this conversion is happening. You just play with the cos and sine graphs. You just shift pi by 2 to the right side, pi to the left side. So I will just show you in the Desmos, then it will be easier for you to understand.
So I have a doubt in odd functions you just showed, na? The f of x, f of x is equals to minus f of minus x. Is it? But it should be f of minus x is equals to minus f of x. Is it the similar
Same thing, right? You just bring minus to the left hand side. That's it.
Okay.
Okay. Is my Desmos screen visible?
Yes.
Yes, sir.
Okay, if you see here now, this particular cos x, I have drawn the cos x graph. So this is periodic. This is in between -1 to 1. But if you see, it is symmetric along y-axis.
Yes,
so
sir.
whatever value I take here, minus of the text. So let me take this 0.93. So 0.93, if my x value is 0.93, my f of x value is 0.598. So if I take 0.93 minus 0.93 here, see the same output 0.598. So whatever the x I take, negative of the x is also the same value I will get. So if I take 5.45, so 5.45 value is 0.673. So the same 5.45, let's see 5.45, 0.673.
Okay, but sir, the sign changes now.
If the
Sign, the
for
sign.
sine graph, I will show you. So this is satisfying because this particular cos x graph is symmetric along y-axis, and this particular cos is actually
This is sign changes because cos of minus x is equal to cos x.
Come again.
So she will asking the sign is changes. Therefore, the sign is changes because the cos of minus x equal to cos x. Therefore, the value comes same at different x.
Still I
Here
didn't.
talking about the symmetry.
So you are asking me about sine graph, right? If I am not wrong.
No, sir. She is asking the value of x. It changes like in something in positive gives the same value something in negative x. This is because the cos of minus x equal to cos x.
Cos x. See, cos
That's
of
why it
minus
is
x is becoming cos x because this particular cos function is an even function.
even function. Yes, sir.
Yeah. See, this is even function because it is symmetric along y-axis. Okay. Now see how my graph is shifting. If I shift it
Left, it will be shifted left.
Yeah, it will be shifted left. So I just shifted it to left.
If the sign is if the sign between the transformation, it will be shifted right, like cos pi x minus pi by 2, it will be shifted right.
Yeah, it will be shifted right side, but I just shifted it to the left side.
Yes,
you
sir.
can see this particular violet graph is shifted towards left side, pi by 2 towards the left side, and this pi by 2 towards left side, this graph is actually the inverse of sine minus of sine x.
Yes, sir. It will come from the trigonometric functions and
Yeah. See, this minus sine x actually took over the black line. See, this particular black line, black curve is same as the red curve.
Yes, sir.
Okay. So what it is saying is cos pi by 2, if you shift cos pi by 2 units towards the left side, it will actually convert to the minus of sine curve. So from there, you can actually understand that cos pi by 2 plus x is minus sine x. If I change this value, this is sine pi by 2. Now see. Now violet curve is sine curve, and I shifted pi by 2 units towards the left side. So if I shift pi by 2 units towards the left side, this curve we just saw, this is the cos x curve. See, the black curve now changed into the red curve. So that means sine pi by 2 plus x will be cos x. So similarly, you can play with not pi by 2, you just take pi. Pi and
by
3.
2
Yeah, 3 pi by 2, pi minus x, pi plus x. You just shift right side, left side, and see these graphs will not change. This new graphs won't come. This will be anyway
shifted, only shifting.
Yeah, only the shifting or inverting along x-axis. It will take the opposite of.
Sir, if we
opposite
add
value.
this constant in function, it will be height will be changes only.
Height changes. That's it.
Yes,
so
sir.
if it moves
Like
upwards.
fx is equal to sin x plus 5. The height will be 5 and minus 5.
That will be in between
Minus 5.
4. So no. 3 to 6. 3 to no 4 to 6. It will be.
No, sir. It will be maybe minus 5 to 5. Fx is equal to sin x plus 5.
This one only, right?
Yes, sir. Yes, sir. Minus 5 to 5.
This will be 4 to 6. See, sin x value will be from minus 1 to 1, whatever the x is.
Yes, sir. Yes, sir. Got
If
it.
this is minus 1 to 1, minus 1 to 1 plus 5 will be in between 4 to 6.
Yes, yes.
Okay. The length of the range will be only 2 for any sine and cos curves. Length means this 4 to 6.
Yes, sir.
4 to 6 length is 2. Likewise, minus 1 to 1 length is 2. Like that.
Yes, sir. Yes.
Okay. Yeah. So yeah, just use Desmos and try understanding the formulas how we got. Okay. They are very easy. If you forget also, this is how you can get the formula. If you know the graphs of cos and sine, that is enough to compute. You should know how we shift. Shifting also you should know. So similarly, you can compute cos pi minus x. So you are actually shifting pi units towards the right side. Cos curve, pi units towards the right side. So if you shift it, you will get the same cos curve, but on the negative side. So this will be like minus cos. Is it minus cos x?
So from the graph,
minus cos x.
we can see that the shifting, while it is shifting, it is converting from even to odd function, right?
While converting, it is shifting.
While shifting, the curve, the waves are shifting from the origin, and it is getting symmetric from the origin. So it is converting from even to odd, right?
Yeah. Also, it is converting from cos to sine, right?
Yeah.
If you are only shifting pi by 2 units, then it will convert from cos to sine.
Yes.
Okay. So from odd to even, it will from even to odd, it will convert.
Sir, is there any significance of the intersection point of sine x and sine pi by 2 minus x? That is the
that is pi by 4.
Okay.
Sir,
So
how
both-
can
exactly the midpoint?
So at this point, both the functions will have similar value.
Same value, 1 by root 2.
Okay.
Sir, how are we saying plus pi by 2 shifting right side, minus pi by 2 shifting left side?
See. You take sine x.
Yes,
you'll
sir.
take sine x minus pi by 2.
Yes, sir.
So whatever the value you take here, if you take 0, this is sine 0. But if you take 0 here, this is sine minus pi by 2.
Oh, yes, it's left side.
It's on the left side. But okay, that means the left value came to x is equals to 0 point.
Yes, sir.
Okay, that means it is moving, it shifted towards right side. So in order to get 0, you should input x is equals to pi by 2 here. Okay, instead of 0, you should input pi by 2.
Yes, sir.
Okay, so that means whatever the x is equals to 0 point has moved to x is equals to pi by 2 point.
Right side shifted.
Right side shifted. So if there is negative sign, it will shift towards the right side.
Okay, sir.
If it is positive sign, it will shift towards left side.
Left side.
Okay.
Sir,
Yeah.
thank you.
And apart from this sine and cos, we have one more function which is called tan x. This tan x is nothing but sine by cos. And where this sine, cos, tan came is if you know a triangle, right angle triangle, and if this is x, A, B, C, the values of these are coming from here.
Yes, sir.
So sine x, this is opposite side, this is adjacent side, and we call this is hypotenuse. So sine x is actually the value which is the fraction of length of opposite side divided by hypotenuse. And cos x is actually length of adjacent side by hypotenuse.
Hypotenuse.
And tan x is basically sine by cos. If you do the sine by cos, yeah, opposite length of opposite side divided by adjacent side. So the values comes from there. Okay. So the tan x will be sine x by cos x, and the graph of tan x is pretty interesting to look.
Yes, sir. It will be breaking at pi by 2. 3 pi by 2.
So this particular tan x graph has infinite number of vertical asymptotes.
So at odd pi by 2.
All every pi by, not odd. Every pi by 2.
Sir, odd pi by 2.
Odd multiple of pi by 2.
Odd multiple of pi by 2, correct. So this will take like an x cube curve, but it is not x cube, it is actually the tan x. So whatever
pi by 2. 3 pi by 2.
This is pi by 2. This is 3 by pi 2. So why the graph is not defined at this point, pi by 2, 3 pi by 2?
So value of tan pi by 2 is infinite. That is not defined.
Why?
Cos pi by 2 becomes 0. That's why.
See, tan x is actually sin x by cos
tan
x.
x
And
by
cos x, if cos x becomes 0, tan x will be undefined. So
yes,
denominator shouldn't be 0. So when will cos x become 0?
Sir,
pi
at
by 2.
pi
Odd
by 2.
multiples of
Pi by 2. Pi by 2. Yes,
odd multiples of pi by 2.
Yes.
Okay, n is odd. Okay, that is why the graph will be like this. Tan 0 will be 0, and as the value of x increases, sin x by cos x value increases, and it will slowly reach infinite while we reach x is equals to pi by 2. And when we reach x is equals to minus pi by 2, it will be opposite case. So even here also you can see tan x is an odd function. We can actually prove it. So how do we prove? We take f of minus x, It will be like tan minus x. This
equal
is
to
like
sine of
x
minus
by
x upon cos minus
minus x.
equal to
So
minus of
as this is an odd function, sine will be minus sine x,
sine
and
upon
this is an
cos
even
x
function. This will be cos x, and this will be
equal to
minus
minus
f of
10
x, and we get f of x will be equals to minus
or
f of minus x. So this is nothing but odd
or
function. So this is how we can prove things. So if you don't know, if you forget also, try to prove. If you know the definition of odd and even functions, just try to prove the things. You take f of minus x and try it. If you get f of minus x as minus f of x, then that is an odd function. If you get f of minus x as f of x, then that is an even function. If you get neither, then that is neither odd, neither even. So if you wanted to prove it like this, you can prove it if you know the graph by inverting along y-axis and later you invert along x-axis. If you get the same graph, then that is an odd function. If you don't get, then that is neither even nor odd. So even the period of tan pi is also 2 pi. From the graph itself, you can see the graph is being repeated every 2 pi intervals. So therefore, this period of tan is also 2 pi. And these are the only 3 important graphs which we deal with most of the times. Okay, so these are very important to note. Okay. So yeah, these all things just now we discussed. So ceiling function will be, if my value is in between -1 to 0, it will take the above integer, which will be 0. If it is 0 to 1, it will take the above integer 1. If it is 1 to 2, it will take the above integer 2. Like this. And the absolute value, we are dealing it from right from week 2, I guess. So f of x is equals to mod x, mod function. This is called absolute value function and also mod function, which is nothing but it only takes the positive values. So even my input is negative, it will convert it as positive and give me the positive value. So the graph will be like this. Mod graph will be like this. So f of x is equals to mod x is this. And you see output, the range is actually a set of all positive reals including 0. Okay. Yeah. Now let's talk about bounded functions. So just now we have seen cos x, sin x. So these two graphs are in between some range. So in between some range -1 to 1. So we say these type of functions are called bounded functions if our graph is bounded in between two values, small m and capital M, like this. So there is an upper value capital M, there is a lower value small m. If my graph is in between these two values for any x, so for every input, if my function is taking values in between these two, then I say that particular graph is bounded. And we say if it is not bounded, or if my function is not in between any two values, we say that particular function is not bounded and it is said to be unbounded graphs, unbounded functions. So bounded examples are like f of x is equals to sin x, f of x is equals to cos x. So sin x and cos x are bounded in between -1 to 1. So our capital M will be 1, our small m will be -1, and whatever the input is, our function value will be in between -1 to 1. So this is bounded in between. Bounded means closed from both.
lies, yes sir.
Huh?
It will lies from
lies and also simply what we say is it is closed from both ends. So it cannot go above that bigger value and below this smaller value. It will be inside this only. So if our functions are like that, then we call it as bounded function. If either one side is open means if it is not bounded, we call those functions as unbounded. So for example, f of x is equals to x square is an unbounded function. So it is bounded below, but it is not bounded above. So this f of x is equals to x square is an unbounded function.
So it means the range have to be bounded, right?
Range have to be bounded. So if I talk about range should be in between alpha, beta, where alpha and beta are real numbers.
Real number.
Okay. If it
So
is not like
it
this,
should be third bracket, not the first. Should be
no,
closed
it can be third bracket also. See, that we will study. See, this particular function f of x is equals to 1 by x square plus 1. You see this particular function, we wanted to check if this is bounded or not. So in order to check that, you know this x square plus 1 is actually greater than 1, right? X square is actually greater than or equals to 0. So x square plus 1 will actually be greater than or equals to 1. Correct?
Yeah.
From there, if this denominator is greater than or equals to 1, 1 by x square plus 1 will be, so it will be, if this is true, then 1 by x square plus 1 will be less than or equals to 1.
1. Yeah.
Correct?
Yes.
So what you have to do is you just divide x square plus 1 on both sides. So if we divide like that, we get the left hand side will be 1 and the right hand side will be 1 by x square plus 1. So 1 by x square plus 1 will be less than or equals to 1. So what I can say is this particular function will take value less than or equals to 1. Correct? Can I say that?
Right.
Yeah. And you see whatever x I input, x square will be positive and 1 by x square plus 1 will be positive. Correct? So x square is a positive number. 1 by x square plus 1 is actually positive. If I say is actually positive means it is actually greater than or equals to 0.
Yes, sir.
Correct? So that means this particular function 1 by x square plus 1 is greater than or equals to 0.
So should we consider 0 as a positive or it's in the borderline?
It's in the borderline. See, when we talk about non-negative, shall I say can I say non-negative?
Yeah, non-negative is the most right term, I think.
Yeah.
Then 0 will be included.
Correct. So this part x square is non-negative, right? X square is greater than or equals to 0. If x square is non-negative, 1 by x square plus 1 is also non-negative. No negative terms are here. So it will always be any non-negative number. So if it is non-negative number, it is greater than or equals to 0 somehow.
Yes.
So see this particular function f of x, the outputs are actually greater than or equals to 0 and less than or equals to 1. Right? So this is actually bounded in between 0 and 1. Correct? So can I call it as bounded function now? So this is bounded. The range is in between 0 1. Can this particular function take value 0? Think about this. Can f of x be equals to 0?
Yes, it can be 0, sir.
When will it be 0?
No, sir.
No.
No, it approaches to 0, it won't be 0.
It won't be 0 at any point.
Yeah, it won't be 0, it will approach to 0. So this will be an open interval 0 to closed interval 1. So the range will be open interval 0 to 1. So if you plot the graph also, this is how the graph will be. See. Have you seen this?
Yes.
See, the graph won't go below x-axis. So it will be on above x-axis only, both sides. And also it will never intersect x-axis. So x-axis is actually the horizontal asymptote of this function 1 by x.
Tending to 0, not intersect.
Yeah, this will tend to 0. That's it. It won't cut x-axis. Okay. So if I see the range now, so 1 is a possible output, but 0 is not a possible output. So the range will be from open interval
Open.
0 to 1.
Yes, sir. Open 0.
Okay. Sometimes you can also see.
Sir, but at 1, it will be closed interval.
At 1, it will be closed interval. I just closed it, right?
Yes, yes.
Okay. If you see this particular function, see this particular function value. Okay, let me give those also. See, if you see here, this particular function will be in between -1 to 1. But it will never take value 1. It will never take value -1. Okay. It might look it is intersecting, but it is not actually intersecting. This particular function e power x minus e power minus x divided by e power x plus e power minus x is actually a bounded function, which is bounded in between -1 to 1. But both -1 and 1 are not possible outputs.
Sir, fx looks like tan hyperbolic x. It will be a sine hyperbolic x
Correct,
upon
correct, correct.
cos hyperbolic x.
Correct, correct. So, yeah, correct.
Yes.
So there will be some functions which are bounded, but it won't take the third bracket. It will take open brackets. Sometimes it will take open brackets. Clear? That is why I just wanted to show this example. Not always the bounded functions will take the boundary values doesn't need to be the outputs.
Okay.
So not always this will be third bracket. Sometimes it will be open bracket. So our key role is that key identification of bounded function is that it should be in between two real numbers. So our function value should be in between two real numbers, a and b. If we can prove this, then we say f of x is a bounded function.
Yes.
So yeah. So even this also 1 by x. Consider this 1 by x and just try to prove whether this 1 by x is bounded or not. This will turn out to be a unbounded function. So the graph of 1 by x will be like this. So it is bounded below, but it is not bounded above. So from there you can prove. And yeah, this increasing, decreasing.
It should not go to infinity, right, sir?
Yeah. This particular a and b should be real numbers.
Okay.
It should not go to infinity. Okay, this monotonicity we just discussed, right? Increasing, decreasing. So f of x1. So f of x is equals to mod x is neither increasing nor decreasing. Arithmetic operations. Yeah. So just now we dealt with functions. And let us look at arithmetic operations on functions. Arithmetic operations means plus, addition, minus,
Add, subtract,
multiplication,
multiply,
division, these kind of things. So arithmetic operations are this. So how will we add two functions? How will we subtract two functions?
Add similar terms and subtract similar.
Correct.
Like
So,
x square term and x term and constant terms.
Correct. So it's just like this f plus g is actually called as the sum function, which is defined on the set A. So let us say f is defined from A to R and g is defined from A to R. So the sum function f plus g is defined on the set A as f plus g of x is actually a new function which is the sum of two functions, f of x plus g of x. So if my f of x is sine x and if my g of x is something like x square plus 2, so if I wanted to look at the sum function f plus g of x, so my sum function will be simply sine x plus x square plus 2. So you just have to simply add those two functions. So in order to talk about the sum function, so this will be the sum function f plus g. Similarly, the subtraction of two functions, which is f minus g. F minus g also a new function, which is actually the subtraction of two functions, f of x minus g of x. The same thing here, f of x minus g of x will be sine x minus x square minus 2. So you just simply subtract one function from the other function. Now the product function. Sairam, I am really sorry. It is better you communicate with chat. Seriously, there is a network issue with you or from my side, or we don't actually sync up, maybe. Is tan x bounded? You tell me, is tan x bounded? So tan x graphs will be like this.
No,
Are
sir.
this bounded between any two real numbers?
No, sir. No, sir.
No. So tan x is not a bounded function. Okay. Yeah. And next is product function. Product function is denoted like this, f dot g. So f dot g or fg or f multiplied with g, f into g, f dot g, fg. So these all are product functions. And apart from this, there is another thing, f circle g, which is different. With this is called as composition of two functions. Yeah.
Function.
So don't confuse with composite function and product function. Product functions are defined or denoted like this, f into g or f dot g or fg. Okay, where fg of x, which is the product function of x, is actually the product of two functions, and this is simply sine x times x square plus 2.
So the whatever arithmetic operation we are doing on the function, it is very similar to the polynomials only, no, sir? Like we are doing.
Correct.
Okay.
Correct. So you can ask me like why we are dealing it again.
Yes, sir.
Right? But those who didn't know, or maybe if it doesn't follow, we cannot guarantee, right? Until we present it to you, you cannot guarantee that it actually behaves like that.
They are only discussed with only algebraic part. Here we discuss about trigonometric and exponential and all algebra.
Okay, and a strong note. Sir? I know actually you will again make, many people will again make mistakes. Note it on this. This will not be equal to f circle g of x.
Yes, sir.
Okay, product function is different from composition of two functions. Even if I say it here, even I will tell it again in revision session, even then I can see some 5 to 10% people will make mistake confusing with product and composition of functions. So that is why I am stressing this more, because I have seen from past students, we are dealing with old students also, right? We have dealt with them, we will deal now, we will deal in future also. So I am pretty much guarantee that, yeah.
So you have written sine x into x square plus 2 sine x, right? It is sine x, right?
Yeah, plus 2 sine x. So it's just the product. You just product this and add this with 2 times sine x. It's just the normal product. Now the quotient function is actually the division function or quotient function, which is actually f by g, which is defined on the set A as f by g of x is equals to f of x by g of x. So which is actually sine x by x square plus 2. Now there is one more condition for this quotient function, is that whenever this division comes up, the denominator should not be equal to is our primary condition, because we are talking about only defined, well-defined things. So when denominator, yeah,
functions are undefined.
Yeah. So when g of x becomes 0, the functions will become undefined. This particular quotient function will become undefined. So our condition should be like, in order to, this is properly well-defined function, call it as a properly well-defined function, our g of x should not be equal to 0. Okay. So anyway, this x square plus 2, I am pretty much sure that whatever the value I take, x value I take, it is not equal to 0.
Yes, sir.
So sin x by x square plus 2 is a properly well-defined quotient function. Okay. So
Yes.
they have given some examples also.
Sir, in that operations of functions, if we say that f and g are two bounded functions, and that applies for all these four properties, so could we say that the resultant is also a bounded function?
Right. Correct. That is one good observation.
Okay. So if any of them,
Can you please repeat the last statement?
I think f by g doesn't follow that. F by g is not bounded.
So if both are bounded, it doesn't imply that f by g
will be bounded, and simple example is the tan x.
Okay, yeah. And sir, if any of one of them is unbounded, so is it necessary that the resultant would also be unbounded?
If f of x and g of x are unbounded, the result becomes f of x plus g of x is anyway unbounded.
Okay.
But f of x minus g of x can be bounded.
So
It
could
will
you show
depend
an
on
example
fx.
if possible?
It will be depends on fx distribution between.
See, one good example is like you take f of x and g of x equal to some same function which is unbounded. Okay. So f of x is unbounded, g of x is unbounded, but the subtraction between these two will be 0, which will be a bounded.
Okay.
Okay.
Got it, sir.
Yeah. And if two unbounded functions, product will be unbounded anyway. Okay.
Okay, sir.
Product and sum will satisfy whatever you said. So two bounded sum will be bounded, two unbounded sum will be unbounded.
Okay.
To unbounded sum, no, sum also won't satisfy. See, what if f of x is x square and g of x is something like minus x square? Okay, these are two functions which are unbounded. But if I look at the sum of some function f plus g, it will actually be bounded.
So like it depends upon the function that we are selecting.
Correct. Maybe product satisfies, I guess. Product should satisfy.
Minus x power 4.
Yeah, product satisfies.
Okay.
One bounded, yeah, the condition is that both should be unbounded, both should be bounded. Then only the product will be bounded, product will be bounded, unbounded product will be unbounded. If you take one bounded and another is unbounded, then again there is a problem. We cannot say. Product also might differ.
Okay.
Okay.
Yes.
Yeah. Okay. So yeah, composition of two functions is, if you have two functions f and g, defined, f defined in the domain D1 and g defined in the domain D2, such that we just talked about this. If you wanted to talk about g of circle f, the x value, the inputs value first goes into f, and then the range of f will goes into g. So therefore, our range of f should be subset of D2. which is the domain of G. So whatever the range of f we get, that should be the subset of domain of G. Then the composition of these two functions is defined as G circle f of x is nothing but the G of f of x. So these things we just studied in week 6. I hope you remember these things. So one example is if f of x is x square and g of x is 3x cube plus 2x. So if you wanted to find G circle f of x, this is not the product, this is the composition. This will be like G of f of x. So G of, you just have to substitute f of x in place of G of x, in place of x here. So 3 times f of x cube plus 2 times f of x. Now substitute f of x. So 3x square whole cube plus 2x square, it will be like 3x power 6 plus 2x square. And if I wanted to compute the product of this f of x product function f g of x, this will be like f of x times g of x, and this will be x square times 3x cube plus 2x. This will be like 3x power 5 plus 2x cube. Okay, understand the difference? This will be 3x power 6 plus 2x square. This will be not equal to 3x power 5 plus 2x cube. So one question is there, just try to solve it. So if f of x is equals to x by x plus a, and it is given that f of x is equals to x by 3x plus 4, then find the value of a. So answer is also given to you. You just try to get this. And let us move forward quickly. Yeah. So let us understand what is a curve or what is a graph of any given function. How do we draw the graph of any given function? The curve is just the simple figure that is obtained as a path of a moving point. So how we define is, if I wanted to draw the graph of function f of x is equals to x square, this particular graph of f is equals to x square denotes or represents a curve which is union of all the points that satisfy this function f of x is equals to x square. And if I plot it on xy plane, this is how the graph will be. So if I start from here, if I move on this curve x square, this is how I will move. And from here again I will move to here. So this particular graph f of x is equals to x square is the union of infinite number of points, and those particular points actually satisfies the condition f of x is equals to x square. So this is, once you plot all the points that satisfies f of x is equals to x square, that will give you this curve. And this is the curve that represents this function f of x is equals to x square. Similarly, we try to plot the graph of floor function f of x is equals to floor x. This is actually not a curve. Instead, this is actually a straight lines or step kind of things.
Step function.
Yeah, step kind of things. This will be like this. Just now we saw this. This is how the graph will be. So this graph we plotted by taking all the points that satisfy this function f of x is equals to floor x. Okay. So this is how we draw the graph, and the graph actually represents the function, and this graph is actually made up of infinite number of points. Now, so this is not a curve. Curve you actually understand, right? Curves are actually like this. Like this. So if I start from one point, I can actually move along this curve.
So a curve has to be continuous, right?
Yeah, curve has to be continuous, and
So then tan x is also a curve. It will
Yeah,
not,
tan x is also a curve.
but it will not continuous.
It is not continuous in some. See, I can actually make tan x is a continuous function if I restrict
In
my
a
domain.
bounded region, yes, bounded.
If I restrict my domain, that will become a continuous function, and then
Yes.
I will call that curve as a tan graph.
Yes. Basically, the locus of a moving point is called a curve.
Yeah. Now, let us talk about the tangent to a curve. So, this particular thing we have slightly discussed in week 4, if you remember. So, for quadratic functions, we actually found the slope of a quadratic function at a given point. Did we?
Yes, sir.
So, any upward parabola at any point, we actually computed slope of this parabola is something like
2ax0 plus b.
Yeah. If my quadratic function is of the form this, the slope of this function at this particular point x0 comma y0 is actually
2a x0 plus b.
2a x0 plus b. So this is actually the slope of the tangent line. So also we discussed the tangent there. Slightly we discussed tangent there.
Yes.
So the tangent line, tangent to any curve at any point is actually at that particular point, in which direction that point is actually at instantaneous direction of that curve is actually the tangent. So a tangent line to a curve C at any point P is a line represented the instantaneous direction. If I say, so I start from here, I'm moving along these points. I started from here, I'm moving here. Suddenly I stop. Suddenly I wanted to check here in which direction this particular point is moving. At this particular point, the direction of this point will be like in this direction. Instantaneous direction.
Means the curve, in which direction the curve is moving also.
Yeah, in which direction the curve. No, it's not in which direction the curve moves. The curve moves along this direction, right?
I
particle's direction. So you say
yes, I got it.
There is a particle here and it started moving on this curve, along this curve. Suddenly at this point, if you didn't see the previous path and the next path you don't know, suddenly at this point, if you watch at this point and you just wanted to look at in which direction it is going, at this instantaneous direction you will come up to get like this. So you think like the direction of this particle will be in this direction.
Yes.
Okay, so that instantaneous direction is nothing but the tangent. Okay, in physical sense this is the tangent, but in mathematics what we call tangent line is actually a line that actually touches this curve at this particular point. It touches and intersects, both are different terms.
Touches at that point.
Yeah, so touching means actually
at only one point.
Yeah, at only one point. At only one point, as well as that particular line will lie either one side of the curve. So the whole line will lie below this curve. Even this is also an line that touches this curve at one point.
But it is not a tangent.
But
it is a normal.
Yeah, this is not a tangent. This is not even normal or some line. Some other line.
But it intersects. It does not.
What?
But it intersects right second line. It doesn't touch it.
Yeah, these are all intersections. So why we call this as intersection is this actually cuts this curve and goes to the other side of the curve. Okay, so these are called intersecting lines, and this particular line is called a tangent line. And please note, for any particular point, if the point is smooth in that curve, there will be only unique tangent, only one tangent to that point. There will not be two tangents at this point. there will be only one tangent line that touches this point and will be the tangent of this curve. So only one unique tangent will be there if it is smooth here. Okay. So any other lines intersecting this point will be intersecting lines. Any other lines which actually cuts this curve at this point is actually intersecting lines. Only the tangent means it actually touches. It only just touches at there and it will go off. And these are the tangent. This is the tangent to a curve. See, from this graph also you can see at this point the tangent line will be like this. But if you see here at P, the curve is actually taking a sharp turn. So if I say the particle is moving in this curve, on this curve, once it reaches this point, the instantaneous direction will be this. But if I am moving along this curve, if I reach it here, the instantaneous direction will be this. Now at this particular point, I got two different tangents. Okay. So what this tells me is, if I get two different tangents at one point, then at that particular point, the function or the curve actually takes a sharp turns. It is not smooth there. Okay. So you can also see here, it is actually from till here it is okay. Suddenly it is taking a sharp turn. It's not smooth. It is coming like this and it is taking a sharp turn here. These are called sharp turns. These are not smooth turns. So if there is sharp turns like this, then the function is not differentiable. The applications will come later in the next step, week 8. So we talk about tangent connecting with differentiability. So if there is a unit,
this sharp turn also come under curves, right?
Sharp turns also, see, these are also curves.
Like sir, I can give one reference. Like in polynomial, it was said that if in any point it is sharp, then it cannot be considered as a polynomial.
That is not polynomial.
Yeah, but here there is no such restriction, right?
Yeah, these are curves. We are actually talking about curve. We doesn't say these curves are actually representing some trigonometric function or some polynomial function or something. These are actually some curves. Okay. Yeah. So if it takes a sharp turn, then at that particular point, we will have more than one tangent point, more than one tangent lines. If you have more than one tangent lines, then we say at that particular point, the function is not differentiable. So we will talk about that in week 8. So differentiability and tangent connectivity, we will talk there. And this is about the point and tangent of a line at any given tangent line at any given point on a curve. See, a line which touches a curve at a point, then the line is called the tangent line to the curve at that point. Now you see which touches the curve at point Q is called the tangent line, and at point P there is no unique line. That is, there are two different lines of different slope touches the curve at point P. So in this case, there is no tangent line to the curve at point P. Okay, so we say there is no tangent line. So if you have multiple tangent lines, we don't know which tangent line need to be picked, and we say there is no tangent line. Ultimately, we don't pick anything and we say there is no tangent line. Okay, and there are go through this textbook. There are detailed explanation of tangent line. Yeah, you can see here L1, L2. This is an example. C is the curve here, and there are some lines L1, L2, L3. So which line is a tangent line?
L2. L2, sir.
Correct. So L2 is a tangent line, and this is an intersecting line where this particular line actually intersects this curve at two places. L1 and this L3 does not intersect the curve. So yeah, so L1 and L2, which one is the tangent? So we just discussed L2 is the tangent. Now let's move on. Yeah, see this example. Now we take floor function. There are 2 points here, P and Q. Now tell me whether tangents are possible at these 2 points. Let's say point P is x is equals to 2 and point Q is something like 3.5.
No, sir.
No. Okay. Okay. See here at point P, we actually don't know. You see the previous and next one, we actually don't know in which direction it is coming and in which direction it is going. Okay. Correct. Left side of P is actually below, somewhere around 1, and the right side of P is in 2. So we actually at point P exactly, we don't know from where it is coming. So it is coming from 1 and it is going directly to 2, and we don't know exactly in between what is happening. Suddenly there is a jump and we don't know what actually is happening at x is equals to 2.
It is also not a curve, right? It is also not a curve.
Yeah, this is not a curve in whole this region.
So can we say that only curves have tangent?
Not exactly. Even straight line, see f of x is equals to something like 2x plus 5. This particular function has tangent, the same tangent. The same straight line itself is the tangent.
Okay.
Will it be the tangent? No, right? Slope of this point. Yeah, slope will be 2 at every point. At every point, slope will be 2. Correct? So this particular straight line has slope 2 means any point you pick, at any point, the slope of the function at that point is 2. So irrespective of the point, my slope of this particular function is 2 at any point. So what this tells you?
That the tangent is overlapping.
Slope is constant.
Slope is constant. Whatever the point you see this particular point has a tangent line with slope 2. So the same.
So can we say that if these lines have tangent overlapping points?
Yeah, overlapping. Correct. So all the straight lines have tangents, which are the straight lines itself.
Yes.
Okay.
All right.
Yeah. Now in this case, at point P, we don't know what is actually happening, left side and right side. So we say we simply say there is no tangent.
So right side we know, right? It is going from 2 to 3.
Right side it is going from 2. See, just right side of P is 2, just left side of P is 1.
Yeah.
What is actually happening at P? We cannot conclude. Should we include left side? Should we consider left side or the right side? Which side do we consider?
Okay.
So there are 2 ways to consider. That is what they are, even here also we are saying. So we say suddenly there is a jump in the graph of the function. Okay. So if there is a sudden jump, we actually do not talk about tangents. And if you see, figure 1.8. If you see figure 1.8 also, yeah, here you see for this particular point I can draw this. This is actually, this line is actually touching point P and it is going. Again this particular line is touching this point P and it is going. This line is also touching this point P and it is going. And there are infinite number of tangent lines at this point, basically. Okay.
Sir, is there any requirement of the tangent to pass through point Q as well?
Of course, right? Which one? Which tangent you are talking about?
Like the tangent which passes through point Q, is that necessary that it should pass through point
It should
Q
actually
also?
touch point Q. It should actually touch point Q.
Like if it passes through point P, so is it necessary that it should go to point Q also? Like that's my question.
This particular tangent line like this?
Yeah. Yes, sir.
No.
It's
See,
only through point P here.
Only through point B. Whatever the tangents we are going to talk, those are related to only one particular point on the curve.
Okay.
Okay. Yeah. See, in this graph also there are infinite number of tangent lines. So at this particular point P, we say there are no tangents. There is no tangent. Simply there is no tangent. If more than one tangent is possible, we say there is no tangent. But at point 3.5, you see at this particular point, you know what is happening left side, you know what is happening right side. So actually you can predict what is actually happening at Q. No need to predict, even though you know at Q also it is the same thing, it is actually following the straight line.
Yes.
So if I start from here, some left of Q, and if I start, the particle is moving towards Q, and after Q, the particle is actually moving along the line y is equals to 3. Right? This particular line.
Yes, sir.
So this particular y is equals to 3 will be the tangent line. Okay. So for straight lines, the tangent lines will be the same straight line at any point. Okay. So one thing you can understand from this is if there is a break in the function, the tangent point of this boundary point, the tangent line will not exist. At these boundary points, we can have infinite number of tangent lines. So if there is a breakage at that particular point, so x is equals to 2 is a breakage point here. So at x is equals to 2, there will not be any tangents. Okay. So, okay, it's already 12:37. Okay. Tomorrow we will discuss what is the sequence and what is the limit. Okay.
Sir?
Yes, sir, I have one question. When you said a straight line has tangent in itself, but tangent only passes through at one point, right?
It actually touches at that one point. Yeah.
Yes, sir. But in a straight line, it is
that is an exception case. Okay. Yeah. So yeah, tomorrow there is a session on week 7 contents itself. So I will ask one of the instructor to go through first 1 hour. He will go through what is the sequence. We are left with only 2 contents, sequence and limit of a sequence,
sir,
and limit of a function. Yeah.
Sir, one request from my side. Actually, on Friday night, I could not attend the Desmos on-demand session. So if I know it is conducted on Google Meet, but if the video is uploaded, then it will be
okay. I will ask someone if they recorded, we will upload. Okay.
Yes.
Okay. Yeah. Okay, then. Thanks a lot, and
thank you, sir.
Yeah.
Thank you, sir.
Thank you.
Thank you.
Thank you, sir.
Host, you can end the session.